Hello, today I'm going to go over this worksheet, Dalton's Law of Partial Pressure. These will be calculations, and it talks about the law down here a little bit, but it's pretty straightforward. You have a total pressure, which we'll call P subscript T. And this is when you have multiple air samples, like in this image here, we have multiple different types of air, or gases, multiple different types of gases in our whole sample of air. And we're going to calculate the pressure of each individual gas, because what you see here is they all have different pressures, and they'll add up to one total pressure. So the way we're going to do this, the total pressure equals pressure of the first gas plus the pressure of the second gas plus however many other gases you have. And on this first problem, we have the total as 1 atmosphere. So 1 equals, I have the first pressure at 0.65 plus the only other one is P2, so X. We've left 3 and 4 blank, so there's no gases there. And then you're just gonna solve this like you would in regular algebra, right? Subtract 0.65 from both sides. And if you do that, 1 minus 0.65, get 0.35. So X equals 0.35. Put your answer over in this last box, which is P2, that's what we solved for, equals 0.35 atm. So that's the pressure of that particular gas. Let's do another one, but they're all set up the same way. I have the total again, 0.97. And we're just gonna add up the ones we got. The first one is the one we're solving for, so that's X plus 0.33 plus 0.45. Nothing for 4, so we leave that out. Solve this like you normally would. 0.97 equals X plus, I'm gonna add these 2 together. 0.33 plus 0.45 equals 0.78. Then I'll subtract 0.78 from both sides, which leaves me X, let's see, 0.97 minus 0.78 equals 0.19. And I was looking for P1, so P1 equals 0.19 atm. So it's very straightforward. You're gonna do all the rest just like that. So follow my examples. All right, thank you very much. And there's one more part to this. It's actually the back. Now the back is set up the same way. We still have our pressures, but you'll see that we have it in a different format here. So I have my atmospheres. We're gonna convert to atmospheres, but we also have this millimeters of mercury. And that's how thermometers work. As air presses down on the mercury will rise and we can tell different air pressures. So not thermometers, I'm sorry, just pressures. If the air pressure decreases, then this line of mercury will go down. So anyways, we need to convert, and then we do the calculations just like we did before. Well, 1 atmosphere equals 760 millimeters of mercury. So I'm gonna take my pressure that I have to convert, and that's gonna go on the top. So this one goes at the top. And then my 760, in this case, because I'm converting, is always gonna go on the bottom. So let's do that. 568 over 760 equals 0.747. We're gonna round that up to 0.75. And now we have atmospheres. So now I can do my regular calculation. PT equals this is 0.75 atmospheres plus 0.68 atmospheres. And if I add these two together, 0.75 plus 0.68, I'll get 1.43. And we were solving for PT, the total, equals 1.43 atmospheres. All right? And that's what you're going to do on all the rest of these, is you have to make one conversion and then add them together like we did on the first page. Now, for instance, remember we're going to take this given air pressure in millimeters of mercury and divide it by 760, which are our conversion factor. If I do that, I'm going to get 1.111, so we're going to round that to 1.11 atmospheres. Now go ahead and figure the rest out over here just like we did up there. All right, thank you very much.